Hello and welcome to our lesson on calculating the volume of three-dimensional shapes. Here's what we'll cover for today. We'll start by understanding how to calculate the volume of a sphere. We'll then move to calculating the volume of a pyramid. And finally, we'll learn how to calculate the volume of a cone. With this new knowledge in hand, we'll move on to applying these concepts to solve problems involving compound shapes. As we work through these techniques, we will practice various examples to apply this new knowledge in various contexts. In our previous lessons, we've established a solid foundation by covering areas of 2D shapes. We've understood how to calculate the area of various two-dimensional figures, volumes of cubes, cylinders, and prisms. We've learned how to compute the volume for these common 3D shapes. We will build on this solid foundation and learn how to calculate the volumes of other shapes as well as the volumes of complex compound shapes. Let's get started and explore these fascinating concepts. Starting with spheres, the volume of a sphere is calculated using the formula 4 over 3 pi r cubed, where r is the radius of the sphere. Note that here the radius is cubed compared to the surface area formula where it was squared. That is because volume is a three-dimensional quantity while surface area is a two-dimensional one. This is also why in volume calculations the units are cubed. For example, suppose we have a sphere with a radius of 3 centimeters. Its volume would be equal to 4 over 3 pi times 3 cubed, which simplifies to 4 over 3 pi times 27 equals 36 pi cubic centimeters. The next shape we'll examine is a pyramid. Suppose we have a cube. We can divide the cube into 3 equal square-based pyramids. What do you think the volume of each pyramid would be? If you said a third of the volume of the cube, then you are correct. Generally, the volume of any pyramid is 1 over 3 times the area of the base times height. Intuitively, this is because a pyramid is 1/3 of a corresponding prism. Suppose we want to calculate the volume of this square-based pyramid. The square base is 3 by 3 centimeters, and the pyramid's height is 4 centimeters. First, we calculate the base area as 3 times 3 equals 9 square centimeters. Then we plug into the formula to get volume equals 1 over 3 times 9 times 4 equals 12 cubic centimeters. The volume of a cone is similar to that of a pyramid, but in this case, the volume of a cone is 1/3 the volume of a cylinder. The derivation of this is slightly more complicated, so we will not go through it here, but feel free to search it up if interested. The equation for the volume of a cone is 1 over 3 times pi times r squared times h, where r is the radius of the cone's circular base and h is the height of the cone. For example, suppose we have this cone with a radius of 2 centimeters and a height of 3 centimeters. We can plug those values into the equation to get that the volume is 1 over 3 pi times 2 squared times 3, which simplifies to 1 over 3 pi times 4 times 3 equals 4 pi cubic centimeters. Now let us combine all of our knowledge and address compound shapes. Imagine you have a cuboid and a pyramid on top of it with the shown dimensions, and we want to calculate its volume. Like we did with surface areas, the key to addressing compound shapes is to treat each part separately. Let us start with the cuboid first. We know that the volume of a cuboid is base area times height. We can calculate the base area as 2 times 3 equals 6 square centimeters. We can now multiply this by the height to give a volume of 6 times 4 equals 24 cubic centimeters. Moving on to the pyramid, we can calculate its volume using 1 over 3 times base area times height. The base area of the pyramid is also 2 times 3 equals 6 square centimeters. This gives a volume of 1/3 times 6 times 3 equals 6 cubic centimeters. The final step is to add both volumes together. Hence, the total volume is 24 plus 6 equals 30 cubic centimeters. Suppose instead you have a cube and a hemisphere on top of it with the shown dimensions. Like before, we will consider each separately before adding them up. Let us start with the cube first. We know that the volume of a cube is side length cubed. Therefore, the volume is 6 cubed equals 216 cubic centimeters. Moving on to the hemisphere, we will calculate the volume of a sphere using 4 over 3 pi r cubed, then half it. The volume of a sphere of radius 3 would be 4 over 3 times 3 cubed, which is 36 pi cubic centimeters. Therefore, the volume of the hemisphere would be 1/2 of 36 pi, which is 18 pi cubic centimeters. The final step is to add both volumes together. Hence, the total volume is 216 plus 18 pi cubic centimeters. In today's lesson, we explored how to calculate the volume of three-dimensional shapes, specifically focusing on spheres, pyramids, and cones. We applied our newfound volume knowledge to compound shapes, calculating their total volume by summing the volumes of individual components. Through examples, we demonstrated how to handle combinations of shapes like cuboids, pyramids, and hemispheres. By mastering these techniques, you're now equipped to tackle a variety of real-world and theoretical problems involving the volume of complex 3D shapes. Keep practicing these methods to solidify your understanding and enhance your problem-solving skills in geometry.